This time, let's look at the graph of polynomial functions in general. We're going to look at the graphs of polynomial functions of d greater than 2. They are more difficult to sketch by hand. However, there are some basic features that are recognizable. These include intercepts, symmetry, and long-range behavior. The graph of a polynomial function is continuous, i.e., has only smooth, rounded turns, no sharp corners. So the graphs of all polynomial functions are smooth and continuous. And so a polynomial function of degree n has that form. We already studied it. So the ones that have the simplest graphs are monomials. Let's start with the idea that the greater of the value of n, the flatter the graph near the origin. So Maple is going to graph two graphs for us. Let's wait for them to come up and we're going to take a look at them. All right, so you'll notice there that x to the fourth is flatter than x squared near 0, 0. Let's draw something else with Maple. We're going to plot x cubed and x to the fifth and see how x cubed and x to the fifth behave near the origin 0, 0, which happens to be the vertex for each of those. All right, notice that x to the fifth, which is the blue one, is flatter near the origin than x cubed is. So now, let's go to the second idea, is that when n is even, and the arrow is going to drop down there, the graph is similar to the graph of f of x equal to x squared. Touches the x-axis at the x-intercept. So let's do some more plotting. X squared and another graph there. Let's see what it comes up with. We just have to give it time, get all of the things typed in. Aha! We have again x squared and x to the fourth. Notice both graphs touch the x-axis at the x-intercept. Now, let's make a statement with regard to when n is odd. Notice the arrows coming down. When x is odd, the graph is similar to the graph of x cubed. So when n is even, it's always going to look something like x squared. When it's odd, it's always going to look like something like x cubed. So we're going to probably graph here x cubed and x to the fifth to just see how it looks. So let's give it time for the graphs to come up. We want to be sure and see this so that we have some idea when we look at a picture of what we're looking at. So we're giving it a little bit of time. Aha, look at there. X cubed is red, x to the fifth is blue. They both cross at the x-intercept. So number 4 that we've just noticed is these polynomial functions of the form f of x equal to x to the n. Notice we talked about even, we talked about odd. These are known as power functions. Notice that power functions are either even or odd.